Hey guys, how's it going? I want to make just a quick video today. I won't make it too hard. I know we're all supposed to be on spring break, but the governor of New York has decided we should work this week. And being as that we're not going anywhere, and this is kind of putting us a little bit behind, it's no big deal. Whatever. Let's get to work. So today I just want to talk to you guys about slope. Okay. We should know slope very well because we did it in, I don't know, the 7th grade, the 8th grade, and the 9th grade. So slope shouldn't be anything new to you guys. Okay. So slope. Slope is just a measure of the change in y over the change in x, right? We'll talk about slope, intercept, form, and all that stuff today. I just want to focus on slope, okay? So if I said a slope was equal to 2, okay? All you need to do is take 2 and put it as a fraction, okay? So 2 as a fraction is 2 over 1, okay? Any number over itself, 2 over 1. So what was that? Your change in y was 2, your change in x was 1. So I'm just going to start at an arbitrary point right here. Okay, and I'm going to say a slope of 2, which means I'm going change in y, right? Remember your y direction is up and down, right? And your x direction is left and right, right? So change in y, positive 2. So up 2, and then my change in x was positive 1. Right, and I can just keep doing that, right? And this was a slope of 2. I went up 2, over 1, up 2, over 1, up 2, over 1, right? And so on and so forth, right? And what we did was we could connect the dots, right? We can go ahead and we can draw myself a little line here, okay? And we could connect the dots, okay? And we talked about this in terms of linear equations and linear functions, okay? We are not really concerned about the function aspect of things because we're in geometry. So we're not concerned with, you went to the movies and adults tickets were this much and kids tickets were this much. We are not concerned with you started with $5 in your bank account and you add $15 every week. We are not concerned with that. We are concerned with the geometric properties of this line, okay? So we are just concerned with how steep is it, where is it in reference to other lines? How do we make shapes out of it? So last year we talked about functions, right? We said they got to pass the vertical line test. They got to pass the vertical line test. We are not concerned with functions. We are concerned with equations of lines and things like that. Okay? We're not concerned with, the meanings behind them other than the shape itself. So if it's a vertical line, great. It's not a function. Who cares? It doesn't matter for us. It's a vertical line. Okay. So we'll talk about that all in time. So I'm going to go over 1 or 2 more slopes, and I'm going to tell you guys why this is important for us. Okay, so let me get rid of all this stuff. Okay, so if I said my slope was, I don't know, 3/8, let's say my slope is equal to 3/8. Okay, already a fraction, so all that means is for 3 over 8. So meaning if I start from an arbitrary point, again, my change in y is positive, right? So I'm going to go up, and my change in x is also positive, so I'm going to go over. So I'm going to go up 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Now 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Right? And again, like I said, we can connect the dots between those points and just kind of see the relationship that exists here, right? Again, it's positive, it goes up. Let's take a look at one that's negative that goes down. Okay, so what if I had a slope of negative, I don't know, -3, right? So again, first of all, what's -3 as a fraction? It's -3 divided by 1. Okay, so my change in y is going to be -3, which means I'm going to go down. And my change in x should be +1, which means I'm going to go to the right. So starting from here, I'm going to go down 1, 2, 3, and over 1. 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 Right? And I can just kind of keep this pattern going and going and going. Okay? So again, this line is going down because it's negative. All right. Now let's talk about what this has to do with geometry, okay? And what it has to do with some of the topics we've been talking about, okay? What if I said my slope was, I don't know, let's pick a nice easy one to work with. Let's pick with 3/4. Okay? So again, my change in y is 3. My change in x is 4. So from this point, I'm going to go down 1, 2, 3, 1, 2, 3, 4. Down 1, 2, 3, 1, 2, 3, 4. Down 1, 2, 3, 1, 2, 3, 4. Go one more. 1, 2, 3, 1, 2, 3, 4. Okay. So here's my slope. Here's my slope of 3/4. Right. Not really a big deal, right? Okay. So let's pick a couple points on here. I'm going to use a different color this time. Okay. So I'm going to pick, say, this point right here and this point right here. Okay. Well, first of all, we know that our slope was 3/4, right? Oh my God, I drew it. Well, we're going to make this negative for a second. Sorry, guys. I drew it down, and you guys were all about to stop, right? My mistake. Okay, so we're going to make this negative 3/4. So I'm going to go down 3 and over 4. Okay, and I'm going to go down another 1, 2, 3 and over 4. Well, what do you guys know about these two triangles? Well, you should know that, first of all, they're right triangles, right? And even though it was negative, it doesn't really matter. This is 3 and this is 4, which makes this 5, which means that this is 3 and this is 4, which makes this 5. So first of all, I know that if I have any two triangles on here, they are congruent. Okay? Now let's take this a step further. So we know that we can use this to tell about congruent triangles. Let's go ahead and let's change this up a little bit and say I have so my starting point here, right? And then we had this point, right? And then we had this point. All right, let's think about this in this terms. To get from here to here, I went down 3 and over 4. But if I wanted to, what if I wanted to go from here to here? Well, this would be what? Well, it's 3 and another 3, so this would be down 6 over 8, which is good for us because not only are these numbers, nice and good for our slope, right? Because -6 over +8 still reduces to -3/4. It also shows us that these two triangles are proportional. Okay, so we will be using, these lines to prove distances, to prove that things are proportional and things like that. And again, we'll do one more just to take it a step further. If I wanted to go from here to this one way down here, well, I went down, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again, still the same ratio, right? So again, lines for slope for us are much more important for showing that things are similar, showing that they're congruent, and we'll talk about things like parallel lines and perpendicular lines. So a lot less about inputs and outputs and functions, and a lot more about the actual properties of these lines, okay? So again, take a look. It's about all it is for today. We'll go over some other things about slope-intercept form and stuff like that tomorrow.